When NASA's next-generation space observatory launches in a few years, the Nancy Grace Roman Space Telescope will expand the search for exoplanets as well as rogue planets, or worlds that travel through space without orbiting stars. The telescope, expected to lift off between October 2026 and May 2027, may have the potential to spot 400 such rogue planets that are similar in mass to Earth, according to new research. It's unknown whether these planets will share any other similarities with Earth beside their mass. Understanding these rogue planets could shed more light on the formation, evolution, and disruption of planetary systems. The telescope is named in honor of Nancy Grace Roman, NASA's first chief of astronomy and mother of the Hubble Space Telescope. Two new studies, both set to publish in a future edition of the Astronomical Journal, point to the discovery of only the second known Earth-mass rogue planet and present evidence suggesting that rogue planets are 6 times more abundant than star-orbiting planets in our galaxy. The findings were made during a 9-year survey called Microlensing Observations in Astrophysics, carried out at New Zealand's Mount John University Observatory. We estimate that our galaxy is home to 20 times more rogue planets than stars, trillions of worlds wandering alone, said David Bennett, co-author of both studies and a senior research scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, in a statement. This is the first measurement of the number of rogue planets in the galaxy that is sensitive to planets less massive than Earth. Seeking rogue planets. Microlensing is a technique astronomers use to study distant stars and search for exoplanets. As stars in our galaxy move, they can align with more distant stars. The foreground star acts as a lens, magnifying and brightening the background star for a matter of hours. But anything with mass can cause this light-warping lensing effect, revealing other celestial objects. For instance, if a rogue planet is in alignment with a distant star, the light from that star will essentially bend around the planet, resulting in a magnifying effect. Researchers can use the changes in light around the planet to measure the planet's mass. Microlensing is the only way we can find objects like low-mass free-floating planets and even primordial black holes, said Takahiro Sumi, lead author of one of the studies and a professor at Osaka University, in a statement. It's very exciting to use gravity to discover objects we could never hope to see directly, but opportunities to spot rogue planets using microlensing are incredibly rare, so a telescope like Roman will come in handy. Roman will be sensitive to even lower-mass rogue planets since it will observe from space, said Naoki Kashimoto, lead author of the other study and an assistant professor at Osaka University, in a statement. The combination of Roman's wide view and sharp vision will allow us to study the objects it finds in more detail than we can do using only ground-based telescopes, which is a thrilling prospect. Astronomers have used a variety of techniques, telescopes and missions to detect more than 5,400 exoplanets, or planets outside of our solar system. Many of these worlds are closer in size to the largest planets in our solar system, like Jupiter or Neptune, and orbit very close to their host stars. But rogue planets are likely much smaller. As planets form around stars, they exert a gravitational influence on one another as they settle into their orbits. Smaller, lighter planets don't have as strong of a gravitational interaction with their host star, so the shifting of larger planets can send these planets spiraling out of the system. We found that Earth-size rogues are more common than more massive ones, Sumi said. The difference in star-bound and free-floating planets' average masses holds a key to understanding planetary formation mechanisms. Engineers and scientists refer to the Roman telescope as the wide-eyed cousin of the Hubble Space Telescope because its massive field of view will create images that are much larger than what Hubble is capable of, all while providing the same level of intricate detail. Roman will be able to observe more of the sky in less time than Hubble, measuring the light from a billion galaxies to help solve cosmic mysteries. The telescope is equipped with a powerful 7.9-foot (2.4-meter) mirror. The never-before-seen images Roman will capture of the universe could help astronomers unlock why the universe seems to be expanding at an accelerated rate, mapping the distribution of matter across the cosmos and measuring how it has expanded over time. With its improved capabilities, Roman is expected to discover around 2,600 exoplanets across the Milky Way galaxy. The observatory will carry a wide-field instrument, with a field of view that is 100 times greater than Hubble's infrared instrument, and a coronagraph that can survey exoplanets. The coronagraph will directly image exoplanets by blocking the light of the bright stars they orbit, capturing details of planets that are 10 billion times fainter than their stars. Roman's microlensing survey will study 100 million stars for hundreds of days to search for planets around them. It's the next major step on NASA's path to finding life outside our solar system, said Dr. Vanessa Bailey, staff scientist at NASA's Jet Propulsion Laboratory in Pasadena, California, and instrument technologist for Roman's coronagraph. Telescopes like Hubble and the James Webb Space Telescope have enabled astronomers to observe large, glowing gas giant exoplanets called hot Jupiters. Eventually, the goal is to be able to observe Earth-like planets and study the light reflecting off their surfaces and clouds to look for atmospheric signatures, Bailey said. Until those capabilities are possible, Roman's coronagraph serves as an intermediate stepping stone. It's going to take the technologies that we pioneered in Hubble, in Webb and on the ground-based telescopes, and it's going to add some new technology to help us improve that performance, Bailey said. And hopefully that means we'll be able to see Jupiter-like planets around Sun-like stars in a few years to see light reflecting off their cloud tops. Roman's targets include true Jupiter-like planets that are cold and more distant from their stars. Instead of the famous pale blue dot image of Earth, Roman will allow astronomers to see pale brown dot images of Jupiter-like planets, Bailey said. Proving what Roman is capable of could lead to the technology necessary to search for Earth-like planets. What I'm really most excited about is that by the end of this, I think I'll be feeling pretty confident about our ability to take that next step, Bailey said.